Okay, a quick introduction of myself. My name is Stefan Steinle, as Peter mentioned already, and I'm here for the Fujifilm Integrated Inkjet Solutions group. And just want to start with a small video, and hope that one works as well. It will show a little bit overall possibilities of our group and what we're doing. But of course, I'm gonna dive deeper into that in the presentation. And yeah, it was really a pity that we haven't met all in person. But I'm looking forward to the live event, obviously, which is coming in a few weeks from now. And again, like I said, that's a pre-flight. So just want to give like a sneak preview of the presentation we're gonna give at the IPI event. And obviously, I'm also very looking forward to meeting you in person at our booth and discuss things. So the name of our presentation is the Redefining Hybrid Printing. So basically what you see here on the picture is just a, picture of a hybrid press as we all know it. There's an analog print section and there's some digital printing added to it. I think that's a technology we know in the industry since 20 plus years, and it got perfected over time by different technologies and different suppliers. And also from the ink side, we saw a lot of progress over the last decades for imprinting. Also Fujifilm positioned themselves in the inkjet market. In 2006, they acquired Dymatics, which is a printhead manufacturer in North America, very known for the Samba head, the current Samba head, which we see in a lot of applications out there, but also some legacy heads like the Starfire head, which is also heavily used. And also Fujifilm made an investment into two actually ink manufacturing sites and R&D sites to produce UV and water-based ink. So I think we're very well positioned for the hybrid printing market, but we want to kind of open the scope a little bit and make it broader. So the mission of the Fujifilm Integrated Inkjet Solutions group, which I'm representing, is to enhance our customers' industrial processes. So we're also talking to the complete industry, and we want to enhance those processes through the use of inkjet technology. And it doesn't stop at adding just digital imprinting to existing print process or replacing analog print process. We really would like to go a step further. And that's, I think, why you're all here is to learn how to complement existing production processes in the industry by adding inkjet technology to it. And that doesn't mean necessarily only marking and coding, which is of course an important part, but it goes a lot further than that. So what you can obviously do is, if you produce a product and adding imprinting in the production line, you can enable late stage customization with the product to reduce inventory and to optimize supply chains. And you can also further enhance the product functionality by adding or enabling consumer engagement, traceability, and anti-counterfeiting, things like that. And overall, it can help you to achieve your operational cost savings and your sustainability goals in the mid and long term. And one fundamental requirement for integrating imprinting into existing lines, production lines, is to retrofit those imprinting functionalities. And that's what our group has mastered since decades now. That's what we're doing, is basically integrating in all kind of processes our imprinting technology. And it started with high-speed web application. It started with flexo presses, but we have more and more demand also from the corrugated market now in the very beginning of the supply chain to add there also imprinting functionality. And that, of course, requires also a high-speed imprinting possibility. Our solutions go up to 500 meters a minute. which is quite impressive, I think. Also, brand owners are looking in late stage customization in filling and packing lines, and obviously product manufacturing on conversion lines are also interested in enabling this hybrid printing. And it starts with monochrome, but it doesn't stop there. So it really goes all the way to process colors, spot colors, primers, varnishes. So whatever need to be inkjet, it most likely can be done as well. And one thing, I think, if you're looking in adding imprinting technologies to your line, is that there are a few things to consider. And then that's basically what we want to highlight in that presentation, is what are the things you need to think of. And, you know, some stuff is obvious, some stuff you might not have on your plate right now. So that's why we want to go a little bit as a sneak preview, as we said, like over the different things you need to consider. So with the application, there's of course the image quality you need to consider. So if you're replacing like a print process, can you reach that quality which the process gives you today, or do you have like other requirements or higher requirements on the image quality? So what's with the performance? I mean, there's a line, so the line kind of gives you a performance, gives you like a requirement of uptime and the speed you need to be able to hold up with, because one thing you don't want to do is obviously slowing down the line. So that's also things to consider. Is there the technology in the market which can hold up with your performance requirements? And compliance is also a big issue. It's not only compliance from an ink perspective, such as low migration inks for food compliancy, but it also is a functional compliancy. It's the final product. So is it, you know, does it have the weather durability, the rub or color fastness it needs? So these are the things you need to really understand in the very beginning of a process to pick the right, let's say, puzzle pieces to build up your solution. The design itself, it comes with a footprint. So there's only a certain given footprint probably in the line. And you need to understand, so what needs to go in order to achieve your performance and your compliance? Like what is the post-production maybe next to the printing? Is it a monochrome? Is it color printing you need to do? What's the curing? What's the image inspection systems? All these things need to be considered if they fit into the given space. What are the conditions? So what is the environmental condition? Is it, you know, lowering the specs of the imprinting functionality? And if yes, so how can the conditions be changed in order to give you the full desired functionality you want to have? And servability, that's a very important point. So how much downtime do you expect by maintaining or maintenance the printheads, for example? Is that something you can do in parallel when the line is running, or do you need to have like kind of redundant systems to ensure the uptime of the line while you need to do the service or you do service? And then the integration. So how receptive is the existing process to add inkjet imprinting? So it also comes down to the line controls. So, you know, is the line or is the substrate handled in a controlled way, or is it a side-to-side motion you have to take care of, a web fluttering? And if there is like an imperfect transport of the material you want to print on, so how can that be improved? And again, these are all the things where our team can give you very valuable feedback, work with you, and bring also third-party suppliers in to ensure that, you know, the final imprinted result is what you expected. The workflow for many people is a challenge. Some of them, as I said, like they're not printers in a way, they don't necessarily know how to handle like data and how to handle variable data. So these are all the things we also work with, how to bring like really the printed result to the inkjet head and inkjet it in the right way. And from the production, the operation, of course, like on every line, you have different operators with different skill sets and maybe also accessibility rights that needs to be reflected, for example, in the user interface. So these are things to consider. The reliability is a very important point. So the OEE, the overall equipment effectiveness, is of course something you need to always consider, and how like adding another module is impacting the OEE, and how can you ensure that the impact on the OEE is as small as somehow possible. OPEX, obviously, operational expenses are very important to understand. Like, what is the cost of ownership? And that's not just the consumables. It's also adding, downtime because of refurbishment or spare parts, ongoing costs with the system. And then the last point is the support. So what training can the solution provider provide to you and your team? So one thing we learned, for example, besides the first initial training, it's always good to have like a yearly refresh training for the operators and new operators to utilize the system in the best possible way. The reliability is also an important point. Like we said, like the uptime, how can we perform maintenance, preventive maintenance, in order to make sure that the uptime is as high as somehow possible. Okay, wrong point, that was the troubleshooting. And the final one is the scale. That's also one thing you need to keep in mind is, okay, is it just one line you need to equip it, or is it multiple lines with the same technology? Is it easy to run multiple lines with one controller, for example? Or is the partner also in a way possible to support you on a worldwide scale? If you have a factory in Europe and one in North America and one in Asia, you need a global partner to make sure that all these installations can be also supported in the best possible way. And that's basically the ideas or the things you need to think about when you think about integrating inkjet in your production line. And we have like a 8 steps process of application engineering, and that's something I would like to highlight. And in the next session at the show, the IPI, in more detail and more depth, really to go into the nitty-gritties to understand like what needs to be done in order to understand your application and make a product out of it, and a final solution to be implemented in your line. These are the industries we're serving today, and by all means, if you cannot wait until the IPI event, please reach out to us and learn with us and talk to us about your integration needs, and we're really happy to work with you and find a solution for your application you have in mind. Thank you a lot for the listening, and I give it back to Peter, I believe. Yeah.
Hi, thank you, Stefan. Excellent. I see that we have one question from Luca. He asks, does Fujifilm work only in the business of adding digital printing functionalities to existing product lines, between brackets, project business, or also as a supplier to OEM manufacturing standardized equipment?
Mm-hmm. So one part of our business, Dymatics, is supplying the industry with the heads, with the Samba heads or Starfire heads, and the integration is then done by the OEM partner. So that's one side of the business. We at Fujifilm Integrated Inkjet Solutions, we look into projects. We provide solutions to usually end customers, but also we are open to talk to other OEM partners and provide a complete solution which they can then integrate into one of the lines they're going to sell. So I think we have like a business division for every route you want to go with the project. So happy to follow up on that one in a personal discussion, of course.
Okay, thank you. Maybe I can add a little question in the same line, but when you also use this word integration, and with integration of print technology in different production environments, it asks a lot of engineering changes. I don't think it's going to be just an off-the-shelf product anymore. It's let's say a tailor-made solution, as you described. What kind of footprint can your installation fit into, and so on. But I hear you also mentioning it's also at the same time, of course, maybe a radical business change. So you also support even there the people that they understand that the implication can expand and have serious new options. So maybe is that then completely a new flexible approach and with multiple players from the side of Fujifilm?
So, like you said, it's really like a new approach we have with the Fujifilm Integrated Inkjet Solutions, because that's what we have done also in the past, especially for brand owners. If they reached out to us and asked for a solution, but they didn't want to really go into integrating a system, we did that always behind the scenes as well. So that's when I said, like, we have like years of experience with integrating systems. But was mid of last year when Fujifilm really announced like that division, which I'm representing, the Integrated Inkjet Solutions group. And this one is really target for providing and integrating complete solutions, including physical integration into lines with all the engineering efforts which go ahead with it.
Okay, thank you. So up to the next speaker.
Thank you very much.
Thank you, Stefan. Our next speaker, Paul Best from ImageXpert, will present his sneak preview. Thank you.
All right, I hope you can see that.
Yes.
My name is Paul Best. I'm Director of Engineering here at ImageXpert, and thanks for being here. I appreciate the opportunity. It's an honor. To speak with you all. Today, I want to give an overview of ink optimization or materials optimization for inkjet applications, and really both covering sort of starting with a broad outline of what the approach that we see many of our customers using successfully is, and then going into a little bit more detail about the exact kinds of testing that our customers are using, the kind of optimization strategies that they're using, and some of the specific results that are being seen. As I think many of you are very familiar with these topics already, and I think some of these topics, you're already an expert on, a greater expert than I. Others of you may be newer to this. I'm going to go over quite a bit of information. Hopefully it's not too much of a blur, but if you have any questions, please feel free to reach out to me either here or afterwards by email. But I want to cover both the broad picture as well as some specific results and some new results. So the first question is, of course, to consider the application. The application requirements dictate what parameters can be adjusted, which ones are fixed, and what will be the greatest challenges. So in some cases, you may be developing a material where the substrate that you're jetting onto is dictated by the needs of the application. Even attributes like jetting conditions or waveform and frequency are dictated by the application. In other cases, you may have free reign to make your own design choices to optimize the entire process from beginning to end. So it's really an important question to ask, what parameters do I have control over and which are being dictated to me? And additionally, what are the most challenging aspects of this application? If I'm doing something new, what are going to be the hardest hurdles to overcome? And what tools can I use to overcome those hurdles? We are, I think many who have been in inkjet development understand the complexity of inkjet in terms of development. There are many factors that go into overall inkjet performance. These are just some broad categories, but within each of these categories, there are many subcategories and additional categories not shown here that all affect inkjet performance. And really, they need to be all considered. This chart is really, it's impossible to make a chart like this that's actually sort of fully complete or accurate, but this is just to give an idea of how all these different factors in the design of an inkjet system, from printhead and substrate choice, ink type, ink attributes, waveform, operating conditions, and many other factors all affect many aspects of the performance of the system. And so it's really not a feasible approach to look only at the final performance and try to figure out how to improve the final performance without having an understanding of each intermediate step and what goes into that. And achieving success at one step at a time is really the way to have predictable and actually faster improvement and faster results and faster either move to a marketable product or improvement to your existing marketable products. Here's their list here of some of the major types of analysis that our customers who are doing materials development are focused on. There are many others, of course, but these are some of the categories that are often of highest relevance. And just to give an overview of this process from sort of beginning to end, this is not a one-way street. You don't sort of completely complete your jetting performance step and never come back to look at jetting performance. It's a bit of an iterative approach, but generally speaking, you would start with making sure that your ink fundamentals are correct in terms of having the needed ink attributes, viscosity, surface tension, other particle size, other attributes to work in the kind of printhead that you're going to use, the kind of system that you're going to use, and also that they are going to obviously achieve what you need for your application, working with the substrate, whatever final requirements there are for the product. Then you would move on to jetting the material and optimizing jetting performance. This is a very important step with a lot of different, there's a lot of different ways to look at jetting performance. There's a lot of work to be done here in this category. But once you achieve excellent jetting performance in all the range of conditions that you need to, you're in great shape for the whole project to be successful. Next step would be to look at ink substrate interaction. That can either be an initial drop impact on the substrate or drop spreading or penetration over time into the substrate. Then how does the printed sample respond to your desired curing and drying process? Print quality analysis, which would include both things like dot positioning or edge raggedness and color matching, but as well durability, other factors like durability as well. And print quality for your, again, all of these depend on the application. So if you're in a printed electronics application, print quality, yes, you're probably going to be measuring things like dot positioning and the quality of your traces or whatever features you're printing, but you may have functional requirements as well. So each of these steps, what you're really looking for here depends on your application. There's no universal process that's the same regardless of that. You have to consider your application at every step. And then of course, sustainability, you want to make sure that the performance you achieve initially is going to work over time, both in terms of continued, production, as well as, in real conditions of starting and stopping, that it's going to continue to work. And then finally, in situ testing, in the actual system, because while it would be a terrible first step to feed an experimental ink into a large printing system, ultimately you do have to test the performance of the actual material with the actual waveform in the actual conditions with the real system. So this is the process we see. And again, it can be iterative. You look at print quality, go back and tweak and look at jetting performance. It's not necessarily a one-way street, but this is the general process that we see. And we're really trying to help at ImageXpert. What we're doing is really trying to develop systems that are as useful as possible to our customers who are following this kind of process. Not so much with ink fundamentals, but everything starting from jetting performance going to the right. We have systems for doing that kind of analysis, and lots and lots of automation capabilities to speed up the process and make each of these steps, more accurate and fast. Not every tool or not every step is important for every application, but we want to make sure that we have we have tools for every application. This is, some of the results I'm going to show are, images and data. Many of them, most of them really are collected on this type of system called a print station. This is really meant to be a all-in-one inkjet development platform. You can see on the left-hand side here, you have a ImageXpert, which is for drop and flight analysis. This is looking at drops as they're being ejected from the nozzle. as well as measuring them, volume, velocity, trajectory. And you can do a lot of different kinds of automation on the jetting, as we said. We'll briefly touch upon some of them. And then we have a station for printing. And then behind that station for printing, you can see there's a camera for analyzing print quality. So it really does everything all in one. And you can use the same driver electronics, ink supply, all in one, go back and forth between printing and drop watching without having to spend time switching between systems, and also without using a lot of ink or other consumables in order to do your testing. So it's really an ideal all-in-one platform for this kind of development. For those who haven't seen it before or aren't familiar with it, this is an example of drops in flight. This is the drop formation. We want to see that tail coming down and collapsing into a main drop rather than forming satellites. This is an example of analysis. We're measuring volume, velocity, trajectory here, and collecting the data. And this is where you would be very early on in this process. If your focus is materials development, you'd be making tweaks to your formulation, changing the viscosity, surface tension, the percentage of the dispersant or various surfactants or whatever materials you want to experiment with, and seeing how that impacts the performance of the jetting performance, and really optimizing around that. In addition to changing materials, if you have control over the waveform, then you would want to optimize the waveform as well. That's trying to optimize the ink without being able to change the waveform at all is sort of like fighting with one hand tied behind your back. It's definitely a great advantage to be able to optimize your waveform for your ink. And we have a lot of, in the old days, you would sort of do this manually, but we have a lot of tools now for automated analysis, automated optimization. You can sweep over waveform parameters to automatically collect data about how adjusting that parameter affects drop formation, volume, velocity, trajectory of the drops. This is looking at from the data perspective, and this is from an image perspective, and you can immediately see in one image how the drop behavior is affected by adjusting the pulse width in this case. This is adjusting the spacing between dampening pulses. This is sweeping over voltage, and you can see how the drop velocity is increasing, and then you get separation with the satellite. Sweeping over frequency, so you can see the stability of the jetting performance versus frequency. This is all automated completely. Analyzing nozzles across the head, and now we can actually analyze nozzles not just across a row, but multiple rows of the head to move to all the nozzles of the entire head if needed. This is actually interesting. This is a study my colleague recently did of meniscus pressure versus jetting behavior, which is something people don't necessarily think about looking at or optimizing, but actually there's a significant effect. Of course, if your pressure is much too high or too low, you're just going to wet out, or the nozzles are going to dry. But even within the operational range of the heads, you have a significant effect on the drop behavior depending on the pressure of the meniscus. And this is a chart versus velocity, but you can also see effects versus volume, drop stability, satellite creation. Here we're looking at moving on from drop in flight analysis to looking at drop surface interaction. This is looking at the drop impacting the substrate live. So we want to see how the drop is spreading when it impacts. In some cases, depending on the application, there's concern about splashing or other effects. This is a fluid on fluid application. This would be more for a dispenser application rather than inkjet typically. But fluid on fluid, you can see these kinds of effects. And then over a slightly longer period of time, we can look at the effect of drop spreading after it's been dispensed. This is particularly useful for, if you're choosing between coatings, which is also material development, coating development. You can see the effect that an untreated surface, the drops quickly coalesce due to surface tension. Whereas with the treated substrate, this is the same ink, same waveform, same everything. It just sticks. So you can accomplish a lot with coatings and treatments. This is looking at the effect of spreading over time. And we can actually not only look at that visually, as you saw in the previous slide, but we can quantify it. So here's the chart of drop spreading versus time after print. And again, depending on your goals, you may want to have that drop just stick where it is, or you may want it to spread. It really depends on what you're trying to do. but a lot can be accomplished by optimizing the coating as well as the formulation of the ink itself. Now, this is new. We have now completely automated multi-pass printing capabilities. So this allows you to print at higher resolutions than the native resolution of the head, as well as wider samples than the width of the head. You can do this with multiple colors as well. You can use this kind of a tool actually to automatically check the print quality versus waveform attributes. So you can print swaths automatically at different waveform attributes or different substrate speeds to see how your ink is performing at different substrate speeds, different frequencies, how it affects print quality. And not only print the sample automatically, even on one sheet, print sample, 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 and see which works best, but you can quantify it there with the camera as well and get numbers straight off of the same without ever removing the substrate. We have now automated Z-axis. This is particularly useful for 3D printing applications, as you might imagine, some printing electronics or coding applications, but also it allows for really precise testing of how distance from the substrate affects print quality. Also, automated completely. The whole thing is scriptable and automatable. And integrated UV IR curing. Obviously, that's very important for certain kinds of testing. You could, again, completely programmable. You can pin one swath, pin it and then do a full cure at the end, cure every swath, cure only the last swath, whatever you need to do. This is dot positioning analysis, which is really the best, most accurate way to measure print quality. This is really useful for a lot of applications, but it requires very high precision, high resolution imaging and very accurate analysis. But we're automatically scanning extremely high resolution dot positioning images, measuring each dot's position and giving a report that shows the position of each dot relative to its ideal. And so you get a dot XY offset from the ideal position in terms of microns, as well as drop shape attributes, axis ratio, roundness, et cetera, for satellites for each individual dot, which is really the most precise way to characterize print quality. And that, again, can all be integrated on the same system. There's, of course, general print quality analysis, more of the traditional attributes of print quality. And then you might move on to looking at sustainability, which means over time, can I continue to jet? This is looking at jets going out over time. Again, automatically sweeping over the head. You can leave it running overnight for hours and hours and hours, and it'll continue to collect data about what jets have failed at what time. If instead of drop watching to do sustainability analysis, you can do sample, print roll to roll in order to, obviously that uses more ink and more materials, certainly, but that's an alternative way to test sustainability with a roll-to-roll system. And then this we're very excited about. This is a new system called Inline, and this is really to complete that final step of in situ testing. So this type of system has angled optics that allow it to work with large print banks. So you can integrate it inside your printer, inside a real production environment and or production prototype, and see the performance with the real ink supply with a full bank of heads and the complete system. You can look at drop the same analysis you would normally do, drop volume, velocity, trajectory, imaging, drop formation, and make sure that you're getting the real performance that you need in the final actual system that you're building. So thank you for your time, and I'd be happy to take any questions. My contact, by the way, is here on the screen. I think it'll be given out as well. I'm happy to take emails to my personal account as well.
Thank you, Paul. We're gonna wait for the further questions till the end of this session, and we will move on to Ramon Borrell from Quantica, and he will show us his presentation now.
Thank you very much, Peter. It's a big pleasure to be here with all of you today. I'm Ramon Borrell. I'm Chief Technology Officer at Quantica, a very young company. I joined only last year, so about over 6 months at the job, but very excited about the company have accomplished so far. Today, I'm going to introduce the company itself, some hints about the technology, the products, and the roadmap for the future. The details about technology and how it works are going to be left for the big conference in May. But today, I think we're going to have a quite interesting introduction. So this is Quantica. Quantica is quite young. It was founded in 2018, and it went public in terms of being known to the public in 2021, in October. So it has been in a stealth mode for quite a long time while developing the fundamental applications. It is located in the Innovation Park in Bullheide in Berlin, a very trendy place for startups. This is where we are doing our R&D and manufacturing. At this moment, it's only low volume manufacturing, but it started recently. It is supported by venture capital, and we are now planning a late-stage funding event that is meant to be concluded in a few months. At this moment, we have 26 employees, multiple disciplines. Almost everybody is in R&D, very highly qualified. We're still hiring top scientific, engineering, and management skills. And we expect to double the size of our workforce by the end of this year and continuing growing for the foreseeable future, because there is a lot of work to be done in developing the products. So we have a vast global of collaborators in different disciplines, mostly technical. And so far we have filed 3 patent families, the very fundamental, and 2 of them are in preparation. As we continue development, of course, there will be much more inventions that will be patented. Our main focus is the development and manufacturing of specialty 3D printers, right? And specialty because we have a new proprietary inkjet technology and the printheads to deliver them that have very special characteristics and enable some unique applications. So our aim is to focus on those unique applications while also allowing others to integrate the technology in other processes. At this moment, we have 1 first generation of printhead in a small volume production. And our main business model is partner with companies that are specialized in certain fields. We share development cost through accepting NREs from the partners. And then we also expect to have a business model by which the 2 partners share the profits from exploitation of the final product. And our desire is to have our primary commercial route via partners, but we are also going to distribute our own products under our own brand. So this is inside the main hall. This is our manufacturing area. It's quite large considering the volume of production that we have now. Excuse me. On the right is the place where components are manufactured, machined. We have a quite sophisticated CNC machines for small components. Then we do our own assembly. We see here 2 large printers in halfway into being assembled. That's the 2 aluminum frames. And on the left side, there's a area with a clean area where the printheads are currently being assembled. So what is the problem that we were trying to solve? One that is very simple. So we have seen so many cases where there is very nice and quite capable 3D printing technologies with one quite severe limitation is that they print a single material parts, right? So a variety of materials and processes, but whether it is fusion or it is like processing, UV curing, it's one material. And this is a very serious limitation for many applications. So the world, if you see any organism, is multi-material. There are layers and there are combinations and there are all sorts of cells and fabrics working in coordination to create something of complex behavior. So we want to accomplish exactly that. So we see 2 types of processes in 3D printing now. Those that are high performance materials, but single material. Example is all sorts of stereolithography or even fusion, powder bed fusion, same thing. On the other hand, we have the jetting technologies that so far are limited to very narrow range of fluid properties, because jetting complex materials is difficult. If there are big particles or high concentration of particles, or the particles are too heavy, or the viscosity is too high, the chemical compatibility is not right, there are all sorts of limitations. Then it can be used, but for not very high value application. They are using prototyping, they are using in a small production of low value parts. What we want is to combine the two things and have high performing materials of many types and multiple materials that can be combined at the time of printing. And the example is some very nice high performing parts like these metal sintered parts. Interesting, but again, single material, more complex figures, but of lower value. So much you can do with representation of individual people or other prototyping single production elements. But if we combine the two capabilities, then we have something that is truly unique. So this is a case of one of our pioneering applications, that is Dentures. This is a very high value part. It sells in the US, whole mouth cost a minimum of $3,000. They cannot be 3D printed now to the right level of quality. They are manufactured sometimes by other techniques that provide a product that is reasonably good, but far from what customers want. So by combining the two advantages, that is high performing materials and multiple materials at the time of printing, we can create a product that is much better, is cheaper, is faster to print, and is much more realistic. And by the way, these materials we are using are expected to live between 7 and 10 years in mouth, not as a temporary replacement, but as something that is very long lasting properties, even in very challenging environments. The key to us achieving this possibility is by the development of a specific printheads. This is a representation of our printhead B1.5 that will be introduced next year. And that was a long story to it, but essentially in 2018, Ludwig Farber, one of our founders, our inventor, decided that what there was in the market at the time, he was trying to print PCBs by additive manufacturing, was absolutely unacceptable, and he needed something better. He decided to invent the technology and to build his own printheads. And surprisingly, he did, because that was a quite arduous task. Took a few years, but the results are quite dramatic. So the process was, we have materials that we need because the properties are essential for what we want to achieve functionally, right? The existing heads don't work. Okay, let's rethink how a printhead should be in order to make it work for that purpose. So the principle of operation needs to be new. The technology to deliver it needs to be new. And there is a large amount of design aspects that need to be resolved. And this is what was the conclusion of Ludwig. He founded Quantica for this purpose, is to achieve funding for accomplishing these development steps and to have a platform for commercialization. What is the result? The result is Quantica printheads can jet fluids of 300 millipascal second viscosity. At jetting temperature, that's more than 4,000 millipascal second viscosity at room temperature. Conventional inkjet have much less capabilities. You see, in that case, we are generous thinking 25, 30 millipascal second. It's true that some companies are commercializing printheads that can operate in a very specific mode that raises that to 100, but there is still quite a long way between the 100 millipascal second or the 300 plus millipascal second. And we have laboratory data suggesting that the 300 can be exceeded quite generously by doing some extra work on waveforms and voltages. the fundamental specification of our first high-performing printhead in volume that will be introduced next year. We call it the ultra-high viscosity print engine 1.5. This will be actually the second commercial version. The first commercial version is in production, but it's much more. So it doesn't meet the productivity requirements of our partners. That's why we are developing a new one. It's based on the same original technology, but fully redesigned. It includes a growing number of interesting features. And it has been fully specified for dental applications, following the requirements of a commercial partner that wants to produce a product for dentures. It will be capable of very high viscosity, actually, ultra high viscosity. Productivity is medium, sufficient for the application. We have plans for more productive printhead in the future. It will have a full fluid recirculation, nozzle plate with a heater and temperature control in closed loop. It has embedded sensors. And as I said, it's going to be introduced 2023 inside a proprietary design of a desktop printer. Here you can see the specification here, 88 nozzles. Actually, we're thinking now of increasing this to 106 to have some margin on productivity. One row of nozzles, 1.1 millimeters each. Other interesting features is the drop volume that can be adjusted between 25 and 600 picoliters by waveform, individual nozzles every time. Viscosity range is quite large, between 1 and 250 millipascal second. This is the official specification. We know that the printhead is capable of a lot more in some circumstances. And it has a quite broad temperature range, a maximum of 110 degrees C. So the jetting frequency will be 4.8 kilohertz. I'm saying provisionally because we're trying to increase it as much as possible during development. And it will have a warranted life of 1 year that should be translated to 30 billion drops per nozzle. Fully functional, all nozzles working according to specification. And it's going to have full recirculation. The nozzle plate in this model is nickel alloy. On top of these fundamental properties, the printhead engineering required some other elements. So as I said, advance some of these characteristics. It needs to be heated in order to control the temperature and therefore the viscosity of the printhead. The nozzles in this model will be driven individually. So you have an external electronics that can adjust each nozzle individually if you want to do that. That includes waveform and voltage. It is manufactured with chemically robust materials. So it has quite a broad range of chemical compatibility. And the design is quite scalable. So we are happy to provide customized printheads to customers who require. It's a quite compact design, ideally for small printers. We are going to have much massive and more productive printheads for other applications in the future, and those will include printheads as many nozzles as 208, 624, depending on the models, with single or multi-material capability. Other subsystems that we are developing are ink systems, driver electronics, recirculation system, a modular print bar, of course, all the software interfaces, etc. Customers might choose to develop a printer with us or to develop themselves, because we might make available many of the subsystems that we are developing for third parties to integrate. Our initial portfolio of products is quite small, so we are starting with this T2 application material development printer. This is a quite large printer, a very open system, and it is intended to development on the lab of applications. So this is for developers to understand how it works, make the best possible use of the technology. And this will be available for sales at the end of 2022 this year. And the star product is the desktop printer. So there will be a family of products. Some will be branded by Quantica, others will be branded by our partners. The first introduction will be end of 2023, hopefully at Formnext. with a number of other models being introduced under different denominations, brands, and different ink systems later. So this is quite small. The print volume is 200 by 100 by 200 millimeters, and it's going to have 6 fluid capability, which is quite interesting for many advanced and complex applications. So applications we're pursuing, of course, are those that have very high value. In principle, small parts, but there is no reason why it cannot be expanded to much larger parts. Some examples are the full dentures, as I said before, very accurate biological or any other type of models, including combination of transparent, opaque, different colors, even glass. Advanced sport shoes and other sporting equipment, metallic and ceramic parts, accurate models for training of surgeons before going to the actual operation, where we can mimic exactly the shape, size, and texture and mechanical characteristics of organs and multiple organs, so that the surgeons can give a trial to the intervention before having to go to intervene in the patient. And at this moment, we have been funded by a number of investors, small investors. There's basically venture capitals and other financial partners, including a large number of angels. We have raised 10 million euros for the development so far, and we are working into a much larger funding round that we expect to close in 3 months' time. We're still actively looking for partners for technical or investment purposes, and for any interest, you can contact me, whether for any technical or commercial inquiries. A lot more will be seen in May. Thank you very much.
Thank you, Ramon. Let's move to the last but not least speaker, Phil Jackman from Sun Chemical. And afterwards, we will have all the questions. Thank you.
Thank you, Peter. Let me just start by trying to share my screen. Good. Hopefully there. So yes, thank you, Peter, and thank you to ESMA for the opportunity to talk at IPI. I think it's a great opportunity to bring together inkjet and other print methods together, really, to really reflect the modern manufacturing that we're seeing today. My name's Phil Jackman. I'm Global Product Manager for Digital at Sun. So that means that I sit within the world of inkjet, where I am a specialist there. But what I intend to do today was give a bit of a capability presentation, really, more to reflect the IPI coverage and what that can mean to industrial print. And at the main event in May will be a bit more application focused and certainly a bit more inkjet focused as well. So for those that don't know us, Sun Chemical is part of the DIC group in Japan, and effectively we're the world's leading producer of inks, coatings and pigments. So we're primarily known really as a printing company. We sell inks and materials to people that print. And within our corporate structure, obviously we've got pigments and we've got ink and press room products, which means products for printers, but we've also got a section called advanced materials. And within there, there's certain subsets, some of which are very much tuned towards industrial manufacturing, and some of that is industrial printing. So on the left, the application materials, that's all different types of adhesive tapes and things that go into assembly of electronics products. It could also mean sort of membrane modules as well. Then fine chemicals, classically it's different lubricants and other materials used in manufacturing. Functional products, we've got hollow fiber membrane technology, sometimes used in water treatments. A lot of the time, those in the inkjet world would know them as degassers. So it's to remove air and dissolve gases from inkjet fluids so they jet better. Then we have a division called liquid components, and this is where inkjet sits, and also other industrial printing solutions such as screen and pad. And then you've got polymers, raw materials that go into inks, certain resins and additives and coatings. So we make raw materials that can be used in printing, but also other applications as well. And then solid compounds, there's a lot of specialist sort of plastic type substrates that are used substrates, but materials, sorry, into manufacturing. I mean, you'll see these in automotive, in engine parts, manifolds and things. They're sort of high-tech, high-temperature resistant plastics these days. So we've got quite a wide spread of materials that we have on offer. But just to go through them a few at a time, I'll do a quick overview of the inkjet part, because this is where I'm most familiar with. So we aim to be a major supplier of inkjet into lots of sectors: packaging, graphics, industrial, of course, textiles, publications. We've been doing it quite a long time, going way back into the 1990s. In fact, some of the other technologies a bit more than that, but certainly the modern world of inkjet, we've been doing aqueous and UV 20, 25 years or more. Very focused on OEM, working with people that build printers, so together we can launch a platform of a tried and tested solution. A lot of our developments have been focused towards packaging, low migration inks or functional aqueous inks, etc. But we do have a lot of chemistries for different applications. Recently, we acquired the Sentient imaging technologies business to bolster our portfolio. That was a couple of years ago now. But still is key. It's working with technology people. So it's people that build printheads, people that build printers. We're really pulling together solutions that way. And we're still very much OEM focused as a strategy, very much working with people that build printers to develop solutions for the growing needs of inkjet printing. We're very much a global business, even though Sun Chemical and DIC are quite regionalized. Because of the specialities of inkjet, we coordinate that from an R&D function and from a deployment function globally. But we have multiple sites around the world. So while we can do the R&D functions in Europe or Japan sometimes, then we can roll those out typically into the regions where we operate. So we're probably one of the biggest suppliers of inkjet chemistry. It's hard to put numbers on it. But we do literally thousands of tons of digital ink every year, and we've got a very wide range of inks and applications. So from the chemistry perspective, having energy curable UV LED is obviously part of us, but also the solvent and aqueous and oil-based inks, hot melt inks, some of the more weird and wonderful chemistries that are often needed in some of these industrial applications. Ceramic and glass inks, high temperature, frit containing inks, etc. And also augmented with primers and OPVs where required. Important to note is, it's not just us in our little inkjet R&D centres. We also work cross-divisionally with Sun and DIC, get their centre of excellences, get their expertise and collaborate so that we can work on solutions for requirements and solutions for customers. And we've got a pretty big jetting science laboratory now, able to support technically most applications and most customers and most printheads, wherever that may be. And then I just want to look at what sort of industrial printing could mean. I mean, this image is shamelessly stolen from the Imprint trade show, but it really does represent the diversity that we see in industrial print. But in a nutshell, you're applying graphics or functionality to a product. That can be parts of a car, it can be solar panels, it can be things we have in our house, from soft furnishings to hard furnishings, electronics goods. Really, the definition of industrial print is quite hard to capture in one or two sentences, but certainly it covers a lot of bases. But it isn't a discrete market as such. It's not just a very finite area of what we work in. It's a group of markets. I mean, we try and define it as where printing is used, but it's not really part of a manufacturing. So it's often used as a manufacturing process to build function or form to a product, but it's not really our customers' main focus. So these guys would make something. They'll make LCD panels, they'll make a car part, and happen to use printing as part of their manufacturing process. They're not typically printers, where all they do is print. So it's quite a different definition. So these guys have to bring some technology in-house, whether that's screen or inkjet or otherwise, but it's really to add something to that product. Usually value, of course, but whether that's adding some graphics, adding some functionality, some or just putting a barcode on there so that it can be part of a track and trace and following the product through its supply chain, etc. And all sorts of print technologies are used. I mean, we can cover them all: screen, digital, pad, offset, flexo, even security printing. But it's all really about getting that end product fit for purpose. It's not really defined by the actual method to get it there. It's about what it does once it's a product. And a good way to look at one of the examples there is a vehicle. I mean, we know them as hunks of rubber and plastic and metal. But we don't really appreciate, unless you're involved in it, the amount of printing that goes on to build a car. Many tens or hundreds of parts in there are actually printed. Obviously the decorative parts, the badges and some of the displays that you can see are printed, but also some of the more functional things, some of the printed antennas or some of the heating components. These can be printed and incorporated into the actual assembly of the car. But also there's a lot of track and tracing, the pick list of parts, and being able to have a 2D barcode on there so that the parts can be assembled correctly, so for identification and tracking and tracing purposes, and also for product marking for aftermarket. The oil filter case has a code on there, and that'll be something that comes with it. And so there's a lot of printing that goes on. Some you'll be fully aware of, and some is very much integrated into the manufacturing process. And certainly of late, the way that the increased level of interactivity, whether that's the car with its surroundings or the car with its driver, the need to integrate electronics into things so that the brain of the vehicle is a lot more informed of what's going on around it. As an example, steering wheels used to just literally steer the car 20 years ago. Now you've got all the controls on there, but also they will have sensors. I had a hire car last year that got angry at me if I took one hand off the wheel because it knew that I wasn't driving safely. It used to put up warning signals. So increasingly there's a level of integration of technology and printed technology into the manufacturing of parts. And this will increase as everything gets smarter. Things will need to have more inputs to create that level of informed information. So looking at electronics, I'm quickly getting out of my area of expertise now, so I'll have to gloss over things a little bit. But certainly, electronics as a market is certainly diverse in what components have to be assembled to deliver those needs. So it's not just printing, but certainly there's the graphics requirement that needs to go into some electronics components. So just applying the graphics or the coloring or the background to the actual physical component that you're building. Obviously, there's a PCB involved. The P in PCB is printing, and it has been for decades. The making of the circuit board, being able to build all those layers up is a tried and tested manufacturing technique. But then these are getting a bit more high tech and integrated. So flexible hybrid electronics is becoming increasingly common as well. And we do all of these components, of course. And then some of the sensors and biosensors, being able to print these and bring these closer to end application needs is important. And then the assembly parts of the tapes and foams to put batteries and screens together, if it's a electronic handheld device, for example. And also we're heavily involved in solar applications, so supplying various different components. So I'll skip through some of the more standard ones. So we won't be looking at graphics and coatings, even though we're obviously very much entrenched in that business, looking at some of the more specialist applications that sometimes people don't know and appreciate some chemical is very much involved in too. So, for PCB, like I say, the P is printed, so, it's been done so for quite a long time. So a lot of the stuff that goes into it is additive or subtractive manufacturing, putting resist masks or building up layers either through inkjet or screen. So it's resisting the etching process, putting some notation in, putting all the white, where components go and the labeling of the PCB. Obviously, it's all printed. It's usually done screen or inkjet. So we've been doing this for some time and very well renowned solder mask in the market. So we can supply all these components to manufacturing. And then more into the flexible world, a bit more, getting closer to some of the newer applications of print, having conductive elements, being able to sort of build in conductive inks or dielectrics, and either through inkjet or screen or otherwise again, but having a portfolio of different technologies that we can bring and work with in customers to try and build up functionality and decorative approaches to whatever components they're trying to build. And then the biosensors, this is the sort of the end interface between what you're trying to work with. It's about bringing portability and instant results for something that would have traditionally needed some sort of lab work. So there's a lot of biosensors for medical, pricking your finger and checking your blood on the spot, or for checking crops and agricultural sensors. Is it ripe enough? Is it good enough quality? Is it top grade or bottom grade? So very quickly the farmers can interact with and know what to do. So there's bringing laboratories and test equipment out into the place where they're being used. But also, going forwards, this potentially could, going back to the steering wheel analogy again, that you could have ways in there that could measure your pulse or detect your sweat levels and adjust mood lighting in the car or adjust temperature and really make that environment for the human that's driving a much better place. So it's a way to sort of build technology either through printing or manufacturing and put it all together into getting the next level of the next generation of manufacturing to meet the needs of what we're trying to do as these products continue to evolve. And the last bit of the technology focus here is looking at electronic materials for the solar applications, photovoltaic panels that you see on houses and things. It's an evolving technology. There's lots of different types of building up the layers. A lot of it is printed. Again, you've got sort of deposition techniques with the conducted parts, but a lot of it is about etch resistance and removing it to give the panels that you need. And laser ablating, resist, all these kind of things that go into, you print and then you remove material in some way. But it's, again, evolving not only as an end application in terms of how efficient they are, but also the manufacturing of those in order to reach those new efficiencies. And also the other complication is, the desire to have them flexible, have them curved, have them built into the roofs of cars, or not just completely flat glass panels that we have primarily today. There are flexible ones, but it is evolving technology, and we evolve the chemistry and we evolve the coatings accordingly as the business evolves. So just really to try and conclude as this pre-flight session really is, industrial print is incredibly varied and incredibly complex. It's highly evolved, specialist at product level, but it also continues to evolve. People are always building new products to meet new needs to further their product development. But the manufacturing techniques and materials continue to evolve as well to push that product development. It's a little bit of chicken and egg. I don't know whether the technology pushes the products or the need for new products kind of pulls the technology to meet it. It's sometimes a bit of both, and certainly it's something that isn't static and it's always pushing boundaries forwards. But products increasingly are interactive, and they integrate the man and machine together, but they also integrate the product with the internet, and everything wants to communicate with everything else. So it's interesting to see how things evolve, but the use of smart printing into smart products is certainly something that is a trend that will continue to grow as things want to talk to us more and be more informed to give us a better experience. And Sun Chemical's got a very wide portfolio, well beyond our inks and pigments business. We can support many applications. Very important as a one-stop shop approach. We can test and pre-proof different layers and how they'll work for customers. We can try and combine different disciplines together, whether that's inkjet and screen or move things across. It's very cross-divisional as well. I mean, I sit in the more graphics part of inkjet, but in the same laboratory, there's guys, jetting conductive silvers, and being able to combine these levels of expertise to help customers going forwards is very important. And of course, people want inkjet, people want digital. They see the ability to version things, to have shorter runs, etc. It's a classic digital requirement. But transitioning from some screen applications into inkjet where possible is always desired by a lot of the manufacturing processes in order to have some sort of shorter run capability, some versioning, adding design elements to something, making everything personalized for people. It seems to have a lot of value and a lot of sort of brand and consumer interaction improvements. So yeah, we're very much a global presence, lots of advanced technologies, and certainly happy to work with any potential partners, customers, and beyond to sort of build up some new solutions tailor-made just for you. So thank you. Like I say, my email address is there should anyone need to contact. I'm not a specialist in all the subjects that I've skipped across very quickly today, but I will be able to point you into the right direction with the correct product manager and the correct expert should any questions become a little bit more technical. And yeah, thank you for your time. Thank you for listening, and look forward to the main IPI event in May.
Okay, thank you, Phil. We still have, I think, some questions which are open. One for Paul. How much space, especially in transportation direction, would you need for an inline drop watcher?
Okay, I see this. Thank you. Thanks for the question. I appreciate it, Roy. And basically, yeah, the nominal dimensions of the inline system are about 450 millimeters by 150 by 100 millimeters, roughly. Usually, in our experience, and this has already been integrated into quite a few industrial printing systems, it's positioned somewhere near the purging. If there's a purging station, it could be positioned down and out of the way. Obviously, it's below the print bank. It can be positioned down and out of the way of many of the more, the main printing process. If it is still an issue with those dimensions, however, there are things that can be done to mitigate that. And we have done custom designs to accommodate the geometry available inside of printers. So be happy to talk about it in more detail if you have a certain envelope you need to fit within. That'd be no problem.
Okay. As you can see, there is now a slide with an overview of all these people, the speakers, sorry, with their emails. You can contact them, of course, directly also with specific questions. We still had some questions, but I will raise them if they're sufficient answered. We had for Fujifilm the question, which we answered directly, but we also had for Ramon still a question, and he answered it, but I will raise it again if there is need for something additional. Can your print heads also be driven by third-party electronics and software like GIS? And
not at this moment. Thank you for the question. Not at this moment. The technology is quite new and it requires a while for the integrators to develop applications. We started a discussion with one of the well-known companies in the field. They are not starting the project yet, but they understand that this is something that is going to come at some point. Also, we need to discuss whether they do the project themselves or we fund them at least partially, etc., etc. So we need to iron out the business model with them. I understand that this is the most convenient way for customers, so we are happy to play this game. Meanwhile, since June, we're going to make available our own internal drive electronics software and in-delivery system for integrators to have an opportunity to try the system and maybe to start developing some applications. The trade-off is our elements will be available earlier, but I'm sure they will be less sophisticated than what other companies in the field are capable of doing because they have a long history of developing functionality on top of their own systems, right? But one way or the other, this is going to happen in due time.
Thank you, Ramon, for completing this question with an excellent answer.